This is me. I'm Carlton Gibson. I'm at Carlton Gibson on Twitter and GitHub. You can find me there. I respond if you put that in and I get a notification. If you don't know me, I'm one of the Django Fellows. So together with my colleague Marius, who sat back there, we do the kind of day-to-day maintenance on the framework. We're contracted by the Django Software Foundation, which is the governing body of Django, to do things like ticket triage, pull request review, handle security issues, do releases, etc. We don't do any of that without an absolutely awesome band of contributors, which will include lots of you. But Django's a project that's so big that there's too much of it to be done just on volunteer work, so it's necessary that there's paid people to do that too. So I always describe us as the janitors. We do the stuff that on a day-to-day basis keeps the framework going. So before I move on, I'm going to remind you that you can sponsor the DSF. Either individually or ideally your company takes up a corporate sponsorship of the DSF. You make a small investment to help secure the continued development of the web framework that you built your business on. It's like having public liability insurance, but for your tech dependencies, okay? When I'm not fellowing, I help maintain various packages in the Django ecosystem. The relevant ones for today's talk are the channels trio, which was originally started by Andrew, but which I took over a little while ago. There's channels Daphne and channels Redis there. We've got some new releases just pending. They're waiting for me to write the release announcement, so there's a tail that needs to wag a dog to get that done, and then I'll get that out. I had hoped to get that out before the talk, obviously. That didn't happen, obviously, but in the next few weeks that will be out. When I'm not doing that, nothing to do with this talk, I've also got a podcast with my friend Will Vincent, Django Chat. We get guests from the community and we chat about Django. If you haven't listened to that, please do. Anyway, bye. Today's talk is about Async Django. Async is one of those buzzwords. It's an exciting topic, but I think there's lots of confusion over what it's really about, and there are questions. What's all this async? What's it good for? How do I use it? And so on. So I've called this the practical guide you've been awaiting for. Well, I thought the pun and then the title was irresistible. Now, async is a totally massive topic, and there's much more than I can talk about today. But it's also a massive topic that, as Katie mentioned in her keynote, we don't have to think about most of the time as Djangonauts. So what I want to do today is focus on just a few examples of using it in Django that bring in the bits of async that are relevant to us, and we can leave the deeper stuff to the group of very clever people who spend a lot of time thinking about and pushing it forwards, which most of the time, it's nice that we know it's there. Katie said be aware of the layer below. Well, we need to sort of have an overview, but we don't need to get in there as Djangonauts. We can do a lot of async and add to our Django applications without getting into the lowest level stuff where it gets complicated, frankly. So, my hope is that you leave with some ideas about using async in your Django application without making it too complicated. So let's go. We're going to start with just a simple async I/O example, just to bring in a few concepts and to set the seed. So first, we can import this module Async I/O. Async I/O is the Python standard library's implementation of an async runtime. It gives you an event loop and lets you schedule tasks, concurrent tasks that will run on it. Right? There are other implementations of async runtimes available for Django, notably the Trio project. But as Django people, as doing async Django, we don't need to think about those. Async I/O is the main async implementation in Python. It's the one that's in the standard library, and it's what Django's async is based upon, okay? At least for now. So, with async I/O in place, then we can define a couple of helper functions. The first one here, it just prints a dot every second. And the second one will take a task name and a time to hang around for, and then it will just print when it started, wait for a bit, and then print when it finishes. Right? They're not very exciting, but they let us demonstrate some things. A couple of things I want to highlight here is in the syntax. The first is the async and await syntax that are used to mark async functions and to signal to async I/O that we're ready to pause the function normally while we wait for I/O, but here we're just sleeping, and we give control back to the event loop at that time, so that it can do something else while it's waiting for whatever our awaitable is doing. An async def function is called a coroutine. And when you call it, it doesn't actually run the code. It returns a helpfully named coroutine object, coroutine function, coroutine. It gets confusing, right? But the coroutine object is the thing that you can await. You can say, go and run this event loop, please. And when you await that coroutine object, your code is paused. The event loop handles running the coroutine, and then sometime later, you get the actual return value of your function, and your code continues from where it left off. Let's look at that. So here's our main function, and this is going to be the end of this first introductory example. First, we use the async IO create task method to schedule our print every second coroutine to run, okay? And then in the loop, we create 5 tasks, name them A to E, and we give them a time to wait. And then, really important step at the bottom, we gather those tasks to wait for them to complete. That's a bit like calling join on a thread, if you've ever used that syntax. Then at the bottom there, we just use this async run method to create an event loop, start it, and run it until our main function completes. So that's the whole script, right? Yeah, you can see, yeah, you can still see that. So, but that's the whole script. When we run it, this is the output. Our tasks, A to E, start. Then our printer dot one gets a go. And then a couple of them finish, the printer dot one gets another one. It's interesting why the dot there finishes kind of appears after the B instead of before the B. And it's because the event loop has a kind of queue of tasks, and it just goes through them in the order that they come up and runs them. And so depending on which order they end up in that list depends on which order they get executed. And so on. Let me just show you one more example. If I comment out that gather call, that one where I said it was important, look, let's go back. That one, it says important, wait for all the tasks to complete. If I comment that out, this is the output, okay? And then what happens is all our tasks start, but then the main function exits, and the event loop shuts down, and all our other tasks never get the opportunity to run. So our poor little printer dot every second, it doesn't get to do anything. So the key point here is we need to not exit our main function because we need a running event loop to execute our concurrent tasks. So thinking about Django, the first question that comes up whenever the async word pops up is, so can I use this for background tasks? Right? So a user signs up. I want to send them an email to confirm, you know, something like that, but I don't want to spend 5 to 10 seconds with the browser not doing anything before I send the request. So could we use async IO create task to send the email in the background? Well, here comes my old man answer. Well, it kind of, and it depends. So let's go through those in time. So can I use some background time? Well, kind of. The question is your background task going to fail? What happens if it goes wrong? Because there's no error handling built for you in async IO create task. There's no statuses, there's no retries, there's no error handling, there's none of that stuff. So if you just fire off a coroutine to create task and it goes wrong, you've got an awful lot of error handling that you need to write with that for that to be robust, where you could just use something like Django DBQ or Django Q or Celery or, you know, if that's your cup of tea. Now, you're all adults, you can do what you like. And maybe in your code you don't need much error handling, and maybe, you know, it doesn't really matter if this task just blows up, but kind of you could use it, but no, not really. Maybe someone's going to build a, you know, a task queue with retries and statuses and scheduling and all these things built on top of async IO, with but it would handle all that stuff. That's not code you want to write yourself. Okay, so kind of. What about, can I use it for background tasks? Well, it depends. It depends on how you're running Django. So there's one more thing we need to talk about, which is WSGI and ASGI. So WSGI, maybe you all know, is the old standard for running synchronous web applications in Python. So Flask is a WSGI compliant framework. Django is a WSGI compliant framework, etc. ASGI, created by Andrew over there, is the asynchronous, sort of modern, not modern, it's the asynchronous version of WSGI. It's for asynchronous frameworks. So Fast API, Starlight, Starlet, Django are all ASGI compatible frameworks. And simplifying, a WSGI app gets the whole request at once and it returns the whole at once. It's kind of one shot. And an ASGI app has It's event-based, and it has a pipe for incoming events and one for outgoing events. And so communication can be long-lived, and it can be bit by bit, and it can be two-way. The point is that in general, under WSGI, we don't have a running event loop. Django allows you to write async def functions which will be run asynchronously with an event loop. But what it does is when the handler, when WSGI handler finds or when base handler finds an async def view, it spins up an event loop just to run that. It runs your view function, and when it returns its response, it will shut down the event loop. So it's like the example where we didn't call gather. We could start a background task, sure, but as soon as the event loop exits, that task would get shut down. So it kind of depends. You could run background tasks using create tasks, but only if you've got a running event loop. Okay? So that's the first example, and there are a few concepts there that we wanted to bring in. The event loop, async and await syntax, that'll do, and gather. Yeah, those are the kind of basics. Now, as Djangonauts, I want to give us one example that I think is very handy. I think this is one of my favorite patterns. And so it's called aggregating views. And what I actually call it is what we did before GraphQL was ever a thing. So let me set that up. You've got an app, and it's an app for hotels. And so you've got a couple of models. You've got hotels, and you've got rooms and prices, right? Then you have some basic DRF serializers for those. You've got hotel serializer, room serializer, fine. And you've got a couple of DRF views. So you've got a hotel detail view and a room list view. And they all work great, and they've got URLs. That's fine. Except your mobile team says to you, we can't make two requests. We've got a view that needs a hotel and a list of matching rooms, and we can't make two requests for that. Quite rightly, right? Mobile connections are slow, data is expensive, connections aren't reliable, they don't want the page to take all day to load. What they want is a single view that fetches all the required data in one go. Now this is exactly the use case for which GraphQL was invented for. But you don't necessarily need the whole GraphQL setup because you can have an aggregating view. Now this is it, can we see that? I'm going to go through that bit by bit. So at the top, first of all, we just import HTTPX, which is a asynchronous requests library. It's like requests, but it's asynchronous capable. And then we import some other bits that we need for a JSON response. Then we define our async def request handler. And from Django 4.1, we can define async def handlers on class-based views, on view subclasses, right? So we get a nice namespace and can decompose our logic into, separate methods if we want to. If you did this with a function-based view, you could denest that a level, and you could get rid of the class, you could get rid of the self, and you could just, remove the indent. But then that's up to you. You can do that. You get rid of the self argument, but you wouldn't then have a namespace. You just have your module namespace to work on. So it's up to you which is more useful for you. And then we get the URLs for the views that we want to aggregate. So we get the hotel detail view and the filtered room list for that hotel. Okay. And then we can use HTTPX's async clients to fetch the URLs concurrently. The client get method isn't awaitable. It returns a coroutine when you call it. And we can use that with async IO gather, again, to wait for all the tasks. So that's essentially which of these requests is going to operate most slowly, wait for them to complete, and then we move on. And then finally, we compose the response structure we needed for our front end, and we return the response. Okay? And that's what the front end team looked for. Now, this is a pattern I've used for many years. Before async IO was around, before async Python, we used to use Node.js. Now, we could have done it with Python threads probably, but Node.js was the thing that you did, so we did it with Node.js. And you'd have a little Node.js service next to your Django app that would provide the aggregating endpoints. And now we can just do it in Django, right? Which is better because when you've got two texts, you've got two documentations to learn two things. It's focus your energies. So the best bit about this pattern, I think, is that you can do this with your existing WSGI application right now. Because Django is capable, under WSGI, under a synchronous running that you've used, your G-Unicorn, whatever it is that you're using, to have these async def views, and you don't need to change a thing. It will spin up the event loop just for these aggregating views, and the rest of your application remains the same. So I think this is a really good pattern. I then want to look at another example, which is a chat app. We're going to look at it 4 ways. And the goal here is to see how the need for async comes in, some different considerations as you go through. So that's the setup. We're going to build a simple app that lets you post messages to a single list, like the old guest books you might see in the late 90s, you know, where you've got just a wall where people post their messages. The channel's tutorial has got a version which is multi-room, and you can have different rooms, and it's worth checking that out in contrast. But what I want to focus on here is how we start with a very simple synchronous thing, and then we add various options on async to change it in various ways. So let's have a model. We've got a message, and we've just got a text field by who it's posted by. We're not going to bother with user and all the rest of that. When it's updating, we just can order by its created for. Let's have a form and a filter. So we have a Django filters filter set there, so we can filter by since. There's a little trick here for Django filters that nobody likes the created at as the URL parameter in Django filters. So you can call the URL parameter since, and then you just say which field name it points to. It's something people like. And then we just have a message form, which is just a simple Django model form that will take the fields for the posted by and then the text that people want to post. Okay. Let's have a view. This is just a Django list view, class-based list view. Let's go through it bit by bit. At the top, just template, context object name, ordering model, etc. Okay. For the get query set, you call the super method, we just run it through the Django filter set in case the since parameter was passed, and then I'm just limiting it to the first 30 records. If there's 400 messages, I don't want to get the whole lot, I just want some. Okay? For the context data, we're going to see if the only interesting thing is for the message form, we're going to give it some initial data if the posted by is in the session, because you don't want to have to type in your name every time. You want to type it in once and forget about it. And then for the get template names, we're just going to use HTTPX, which is what's it called? HTMX, that's the one. We're going to use that. Sorry. I went to the party too. We're just going to use HTMX if we want that, and why not? Because that's great. That's it. That's quite a basic list view, and then we're going to add 2 bits. Yes, we're going to add a post message to create the messages, which is just again standard create view based on Django's generic class-based views. There's 2 bits I wanted to call out there. One is that the success URL, we're going to just redirect back to not the object detail, but back to our list view. So we've got the message board. From the post view, we don't go to a detail for individual messages, we just see the list each time. And then the second bit was that if the user did put a posted by in, then we will save that in the session. Okay? So, we're going to look at 4 ways that you could deal with this if you want to update. I want to know, I've got my message list open in the browser, and I want to know when it's updated. If someone else posts a message, I want to see that. And so how do I do that? The first way I could do it is by polling. I could request every 5 seconds, every 10 seconds, and check to see if there are new messages, and if there are, I can update the HTML in the browser. So HTMX, yes, thank you, does this for us so I just put a checkbox here, type checkbox, I hit the list view, because it's an HTMX request, it will just send the formatted bit that I want to swap in. I give it a target, I say, look, I want to go and replace the message list ID, DOM element, and a trigger when I check the checkbox start, and then every 5 seconds send another request. Right? Now that might well be all you ever need. And that might be perfectly good. And if it is, stop there. Right? Well, but scaling. Right? What if I've got lots of clients and they're repeatedly making requests? Right? Now maybe it's big enough, but likely you wouldn't, at some point it's going to start getting a problem. What about responsiveness, you might say? Like 5 seconds is quite, well, it might be a long time, 10 seconds might be a long time. I want my app to feel responsive, so if someone posts, I want to reply straight away, Now I could poll more frequently. I could say, well, okay, let's poll every 1 second. But then that scaling problem becomes a lot more serious. And so there's a sort of a ratio between how long do your requests take and how often are you hitting them and how many clients have you got. And if that sort of reaches saturation, you're in big trouble, okay? So at that point, you're essentially DOSing your own application. So if it's an internal user face, there's only one user and it's only one browser session, yeah, fine, polling. But if it's, hundreds of users concurrently, that's not going to scale. So that's when we have the second strategy. And I want to introduce that's long polling. And here we get beyond what we can do with Django itself, because we're kind of changing the schema of what we want to do. We want event-based or real-time updates, and that's not what Django was originally set up to do. We go from the traditional request-response model, where we the view gets the request, and then it sends the response, to the second model, which is event-based, where the view gets the request, it somehow waits for an update, and then it sends the response. And we can't do that with traditional Django views. There's no real option for waiting. I mean, you can synchronously block on a queue, which is, no. So this is why this waiting bit, this need to be event-based, is why we need async, right? We need to respond to events, and we need to be able to communicate between requests, between open browser windows, basically. For this, we need the channels package, which, again, Andrew created. And this is a few parts. The ones I want to talk about today is a channel layer, and this is a way of sending messages between different connections. So you post a message, I want to hear about that, and the channel layer is how we do that. Essentially, you have a Redis instance or something else, and a message goes via that to anyone who's subscribed, and you send out to a group of all windows saying, hey, a new chat message was posted. And then the second component that we need is consumers. And consumers are essentially user-friendly abstractions on top of lower-level ASGI. Okay, so we, as Django developers, don't want to spend our time worrying about the details of ASGI. It's a bit gnarly, and there are gotchas that we don't need to know. So on top of those, consumers make writing your async apps a bit more human, a bit more Django-like. Now, all of this is in the channels docs, and if you follow the channels tutorial, you can get the feel for it. But I want to go through an example and sort of show you how it comes up. So the first thing we need, if we're going to update our message list, I've got my browser open, I want that to update, is we need a way of notifying when a new message is posted. So we create just a helper function to do that. And for this, we use the channel layer. And basically, we need to send a message to the channel layer and saying, hey, there was a new message. So first of all, we instantiate the channel layer, or we use this get channel layer function, which gives us an instance of the channel layer, okay? And then this is a synchronous function we're calling. We're writing here, you'll see why in just a second. So we use the wrapper from the, I should have put an import statement there, anyway, but it's from the ASGI ref package, ASGI ref sync, so it's async to sync helper. And that will turn an asynchronous function into one that we can call synchronously, okay? And then the channel layer has this concept of groups. So I want every browser window that's open to get to be updated. So we have a group for that, and that's just called chat in this example. And then we send it this dictionary here, which is the message itself. Now the key field there is the type. Every event that we send to the channel layer has to have this type, and Yeah, I'll come back to why. But the bottom line is consumers know how to map the type of the message to the handler that's going to deal with them. So consumers will have a handler which is chat_message, and they know when they get an incoming message, look for a handler that matches this message type and dispatch it. That's why the type is important. The message here doesn't matter. You can have key values, but the values have to be like essentially basic. They need to be serializable. They can't be model instances. You can send model IDs, but not model instances, because you're going to pass them into a different thread, and you can't pass model instances across threads. That'll all go wrong. So, with the notify message in place, we need to just make sure it's called whenever we create a new method. And we do that in our post view, in the form valid method. We're just going to call the notify message when the transaction ends. So we use the transaction on commit callback there, because we might have atomic requests on, we might be inside a transaction. If we call it just on form save, well, the object won't be in the database. We'll send the message. All our browser windows will go, oh, refresh, can I have some normal data? And there won't be any new data. And they'll be like, oh, what's gone wrong? It's because we didn't wait for the transaction to finish, right? That's a little Django gotcha. And then we just call it. Transaction on commit will fire the notification when the transaction is committed, and that's it. We don't need anything else that's the notification side. That's like, hey, an update's ready to go, okay? So then we need to listen to it. And here's where we need the consumers. So this is going to be a long poll consumer, and it's an asynchronous HTTP consumer. So long polling is just like polling. What you do though is you wait around. You get a request and you hold on. You just don't reply. You send some headers to say I'm going to start replying, but you don't reply. And after a timeout, the client will normally disconnect after a particular timeout, or you might time out yourself. But if an update comes, then you send the response at that point. Okay? So the first thing we have to do is we're just going to set a send state, which we're going to use later to say any messages created from when the request started. Then we could get more clever, but we don't need to for the example. And then we add ourselves to the channel layer, to the same group, same chat group that we're sending the notifications to. And what that says is, hey, when a notification arrives at that group, at the channel layer, please forward it to me so that I can be notified. And then when we disconnect, we need to remove ourselves from that channel layer, okay? Then we just need a helper method to fetch new messages and to render them. Now this is a sync method. This is an important bit, okay? This is a sync method. We could use the ORM's new asynchronous query interface, but we're going to take the model interfaces the model instances that we get back, and we're going to render them in a template. Now, template rendering is a CPU-intensive operation. It takes time. And if we were to do that on the event loop, in our async def function, we would block that event loop, and it wouldn't be able to handle any other requests. And so template rendering is something you want to put off to a thread so that the event loop can carry on serving requests while the template's busy rendering over here. But we can't pass ORM objects through into a thread, into another thread, in order to render them in the template. So what we'd have to do if we use the asynchronous query interface is we'd have to serialize those model objects into dictionaries and then pass those dictionaries into our function, into our threaded function, which is going to render the template. But that's a lot of work. It's much easier to just put the whole lot in one synchronous function, fetch the objects, and render the templates together, and then call that once from the asynchronous view. So let me show you the calling the thing. Here's our chat message. This is where we listen to the events. So if you recall, we sent that message of type chat.message. And here the method name is chat_message. And the point is channels knows to take the message type and mung it to it. You can't have chat.message as a Python identifier because that's not a valid identifier. So it knows how to mung the message type to a handler and call the right handler. So we will get passed in that event with just the message string, which we don't have. Then we use sync to async, which is, did we use that before? Did we use the other one? No, we used the other one. We used async to sync. Now we're going to use sync to async, which enables us to take a synchronous function and then await it, execute it in a thread pool and wait for it to finish, and then get release control back to the event loop and wait for it to resume when the response is available. So we get the HTML from our message list helper, and then we send the body down to the client. We use the send body method enables us to output the response. The more body false bit there says, and stop the response, close it. This is long polling. We get a response in, we wait for an update to arrive. When the update arrives, we render the template, we fetch the data, render the template, send the response. Job done. The upside here is that we get a new message just as soon as it's posted. So it's responsive. We've solved that responsiveness. But okay. And the upside, so rather than polling, rather than having the polling interval, we get the response instantly. So that leads us on to the second option, which is server-side events, which is the same idea, but a slightly different version on it. With long polling, when we get the chat message event, we finalize the response, and that says the end of it, let's close up. And that's like the polling example, it's a traditional request response. We get the request, we send the request, we get the response, but there's just a little bit of waiting in the middle. But most clients will then go and immediately reconnect again. Right, so they're going to ask you, are there any more updates now? What are you doing now? What are you doing? What are you doing now? What are you doing now? Right? There's overhead to that. So let's assume that even if our web server conducts requests at zero cost, which it doesn't, right? We've still got a cost because we're still adding ourselves to the channel layer, we're removing ourselves every disconnect, all the rest. So server-sent events is for that, well, can't we just keep using the same connection sort of idea? And so, yes, we can. So here we have the server-sent events version of the consumer, and it's kind of exactly the same. In handle, we connect to the channel layer group exactly the same. In the disconnect, we do exactly the same, and we have exactly the same message list HTML helper that goes off to the ORM, fetches the new objects, and renders the template, which we call by sync to async. The only difference is in the chat message handler, the one that when we get when we send the notification from the form creation view, gets called in response to the update. We have the same sync to async call to the query ORM render template, and then we have to format the event to send because server-sent events can't have new lines in them because they're delimited by new lines. You get a kind of event injection if you didn't get rid of them. So we take all the new lines and we prefix them with this data. Each line in server-sent event in an event body has its data colon line of stuff, data colon line of stuff. And so we just format it like that. We add a couple of new lines, and then we send it. It's almost exactly the same, except at the end, we pass more body equals true. And that says, hey, I'm going to follow up with more here. Please don't close the connection. There's going to be another one next time. And so instead of having to disconnecting, reconnecting, and all of that, I just keep waiting for more and more. And HTMX or whatever you're using can take the HTML, put it into the DOM, and then just wait for a bit more. And HTMX has an extension which handles all this for you. And it just goes in, it's same attribute-based, target that selector, all done. Okay. If the connection fails, HTMX will take care of reconnecting, but in general, we just keep the same connection going for the lifetime of the browser session, which is nice. So that was polling, long polling, server-sent events, and then the fourth option is WebSockets, which might be the one you jump to straight away because it's very popular and there are library support and things like this. It's what you're going to want to use if you're building SPAs, or you want to keep sending data back from the client, because the difference between the examples we've talked about thus far and WebSockets is WebSockets allow two-directional data. So for this example, we're not going to rewrite our post view to send the new message via, we're just going to keep using the forms. We've already written it, and as Djangonauts, we're not going to rewrite that to something more complex. We're just going to use it. But in principle, you could. And if you're using, JavaScript libraries, they'll do that. HTMX, again, has a WebSockets extension, which you can just, wheel out and use. Bam. Okay, let's look at it. So here, it's exactly the same again is the queue. And this is as Django developers, this is the genius of channels and the channels consumers, is that they have this nice Django-friendly pattern, and it applies to all these different methods. With all I've done is change the import and change the superclass, and then I've got this chat message implementation, which is, oh look, I call the self-message list HTML helper in the sync to async so that it can go and query the new models, render the HTML, give me back the HTML, and then I can just use, on the WebSocket consumer, I can just use self.send and say, hey, we're sending text data here. Because you can send binary data and other things. And that's the 4 different ways, right? Again, HTMX has got that extension. So which should I use? Well, polling is simplest, right? If you've not got a lot of clients, not got a lot of requests relative to your response time, and small delay doesn't really matter to you, 10 seconds is fine. I'm not in a conversation here. I just want to know, if someone scored. If it's 10 seconds later, that's fine. My view is that the best software is the software nobody wrote. No software, right? So you've already got a Django app that just works. And you can add polling with that, those few HTMX attributes, and it's job done. Stop. But if you've got a lot of clients, lots of connections, and then that's when you want one of our other 3. For Django 4.2, if it's feasible, we'd like a story for streaming async responses in Django itself. So at the moment, you can write the aggregating view, the example I gave, the async def, and that returns the response. But what you can't do is stream a response like the long polling requires or that server-sent events require, so you need channels. But maybe if we can get it in, we'll try and get that in for 4.2. And then you just write with an async def, otherwise you can use channels. If you want real-time responses though, then you've got to use one of the async options. You've got to use long polling, you've got to use server-side events, you've got to use WebSockets. If you want two-way, well then you've got to use WebSockets, right? If you just want to get something from the server, well, one of the other options is available. But if you want a conversation on the same connection, rather than, a side path, you need WebSockets. You might find that your chosen libraries support WebSockets already. It's quite popular, it's very established, and it might just be, oh, do you know what? We're using this library, it's just a change of import from channels, let's use WebSockets rather than a streaming HTTP response. So the answer is, hey, it depends. Right. I just want to finish off a few thoughts about getting it online. Okay? So at the beginning, we said WSGI or ASGI. Well, hang on, what about WSGI and ASGI? At least for now, right? Async is something that we're still working on. And I don't mean we in Django, I mean everybody's still working on it. The patterns aren't 100% clear. There are bugs and gotchas that you sort of have to learn the hard way, and it's still kind of a bit like the Wild West. Okay? Compare that to WSGI, where we've got 15 years of rock-solid experience to build on. Okay? Every problem that could come up, kind of, already has, and it's already been fixed. The scaling patterns are known, and frankly, why wouldn't you use it, right? You can deploy totally on ASGI. It's not a problem, you can. 6 feet up, right? They built the Loud Swarm product, which we used for the conference, the DjangoCon conferences after the last few years. It's brilliant. It works great, but 6 feet up are a very experienced team, and they've got a lot of ops, capacity to make sure that it's working correctly. Maybe you haven't got that. Maybe you don't want to spend the time it takes to make sure everything's robust. Maybe the best thing for you to do is to deploy your core app with WSGI, as you exactly are, and then just have your async code in an ASGI app on the side, and then Nginx can route the request just to the ASGI app. Keep it simple. Go to bed at night when you're on PagerCall knowing that at least the core of your app isn't going to wake you up, and maybe it's only one or two endpoints that are experimental that might. So that's one thought. And then the second thought is double check everything. Most of the issue reports that I see on channels are problems with the setup. Generally it isn't channels or it isn't Daphne, it's whatever you've got in front of that. Like maybe your load balancer isn't configured for long-lived connections. Maybe your web server isn't using the right HTTP version, so the WebSocket upgrade thingy bob never quite works. Maybe that. And the trouble with issues like that, I can't help those issues, so they sit there forever unanswered. Right? So build it out. Check it works with just your app. Check it works going via just the web server. Then check it works going via the load balancer. Check it with an active connection, one that's that's noisy. Then check it with an idle connection, because a lot of people it's all working fine, and then an idle connection, so it just disconnects all the time. Like, why? Well, it's because of a request timeout. Maybe at the load balancer level, wherever. How long do you want connections to be open for? Ask that, and then tests that they can stay open that long. I want them to be open for an hour. Okay, so have you actually got tests that they can stay open for an hour with your setup? Do you need to be sending periodic lifetime events? Because a lot of this can be fixed just by sending a heartbeat every, your load balancer will kill your connection after 30 seconds. So 20 seconds, send a heartbeat, bam. And that keeps it alive, and it fixes lots of problems. And then the third point for getting in the line is to have fun, right? Async is really interesting. There's lots to learn. I mean, it's lots to experiment with. I think of it as programmer catnip. It's just like, right? So have fun. What are you waiting for? I'm Carlton Gibson, I'm your friendly Django fellow. I'm Carlton Gibson on Twitter and GitHub, you can find me there. If you haven't listened to the podcast, do check it out, djangochat.com. Hope you enjoyed the talk. I hope you've got a few ideas about whether and how you can add async to your Django application. If you've got any questions, really happy to talk to you through the rest of the conference. Thank you.